In this lecture, we're going to dive a little bit deeper into the concept of tokens in dependency injection. And by the end of this lecture, you're going to know the three different ways we have of defining tokens in Angular. So there are a number of different types of tokens or ways of defining tokens we can use when configuring providers. So we can use strings as tokens, as you can see from the example we've got in front of you right now. We have provided, and the token we provided is just the string email service. So when we request a resolution, we pass in the email service as a string. Although it's possible to use strings as tokens, their use isn't really that recommended, and instead it's preferable to use either type tokens or an instance of something called an opaque token. So we can implement this same code, but instead of using strings as a token, we can use a type. Specifically, we can use a class name as the type. So if we implement this code with both the mandrel service and email service, extending a base class called email service, we'll do that to begin with. And then we can use the base class email service as the token and not the actual string email service. So then when we want to resolve a dependency from the injector, we just pass in the name of the base class. Now we could actually use any class name really. It doesn't have to extend the mandrel service, and the SendGrid service doesn't have to extend the email service for us to use the email service as the provider token. I just think extending the classes that we want to use from a base class and using that base class as a token is just a lot clearer. And actually, in fact, I've created there's a bit of an error there. That's not quite right. It should be extends email service should be there. So now if I run this application, I'm expecting mandrel service to get printed to the console again, and it is. So the third way of defining a token is via an instance of something called an opaque token. So we need to import opaque token from Angular core in order to use it. And then let's create an instance of opaque token. In fact, let's create an instance called email service. So let's do it this way. And since it's not a class anymore, we can remove the extends. And now we can use the email service variable wherever we would use the token. So we can provide it in a provider, and we can pass it to the injector when we want a resolution. And if we run this, it should work as normal, and we should get mandrel service printed to the console, and we do. So just an important note, the actual string that we pass to opaque token when we construct it, this is only used to print a meaningful message to the developer when there is an error. It doesn't actually need to be unique. So this could actually be foo, moo, whatever. Whatever string you pass in here is just going to provide a helpful error message so you know what's causing the error. So you can kind of trace it down a little bit. It's not actually needed to be email service or to be anything in particular. So if using a base class as the token is not an option, then using an opaque token is the preferred method over using strings, because it prevents name clashes that can occur. So to explain that, let me kind of rewrite this as if we were using strings and just demonstrate a problem that can happen just by using strings. So if I create two string tokens, one called mandrel service token and one called SendGrid service token, and then let me also configure another provider for SendGrid as well using the SendGrid service token. And now let me grab the two email services from the injector using the separate tokens. So I pass in the mandrel service token, and I'm hoping to get the mandrel service, and I pass in the SendGrid service token, and I'm hoping to get the SendGrid service. So now if I console log the equality of both of these, let's see what happens. So actually it returns true. So that's because actually both of these injectors are returning the same instance. Now we tried to use the string tokens, mandrel service token and SendGrid service token, but they happen to use the same string email service. They happen to point to the same value of a string. So actually this code is equivalent to just providing the same provider with the same token twice. And when configuring an injector with the same token multiple times, the last provider just overwrites the previous provider. So actually, our injector is just configured with the SendGrid service. So when we request from the injector the same token, we're actually just getting an instance of the SendGrid service. And that's why this line here is printing out true, because it's the same instance of SendGrid service. Now, this example might feel just a little bit forced, but the issue is actually quite real. It's really common for different third-party libraries built by different people or teams to just by accident use the same configuration strings. And this is something that happened in Angular 1 quite a few times in the past. Different people just come up with just too simple a configuration name, and then multiple libraries use the same one, and then we have a name clash. And Opaque Token solves this shortcoming of using strings as tokens, since each instance of an opaque token is unique, even if it has the same descriptive string passed into it. So if we coded this up using opaque tokens instead, and then we provide two providers, one for mandrel service, one for SendGrid service, both using the one using the mandrel service token and one using the SendGrid service token. And then we run our code again. We'll see that now false gets printed out because both of these dependencies are different. In fact, let me print out both dependencies as well. So we get mandrel service from the first. So we get mandrel service when we request the mandrel service token, and we get SendGrid service when we request the SendGrid service token. So even though both of these tokens, this mandrel service token and the SendGrid service token, even though they have the same descriptive text being passed in, they are not equal. They are considered two separate and unique tokens, and therefore the injector returns the correct dependency for the requested token. So in summary, a token can either be a string, a class, or an instance of opaque token. And string tokens can cause name clashes, so we prefer to use opaque tokens instead. In the next lecture, we're going to look at how we can actually configure dependency injection in Angular.